It's space weather! Looking at the northwest corner of the sun, a gigantic filament. It's about 6 Earths in diameter right there. Check it out. It's still there right now, by the way. This has not yet dissipated. Don't worry about coronal mass ejections from that. It's awfully far to the northwest. Now, space weather has dropped in intensity. Take a look at the incoming coronal hole's magnetic lines. While it is connected and very powerful, it will be a few days before the wind stream shows up from that. And so the magnetic connection will continue throughout that entire period. Take a look at the local star in 171 angstroms. Not as boring as it could be. And before we go on, let's take one moment, since there are some folks interested in learning about space weather and the sun and so on. Please head to YouTube and go to Sky Scholar, a channel hosted by Dr. Pierre-Marie Robitaille. He is an Ohio State radiologist. Make sure you like and subscribe to the videos, but what I want you to do, click on videos, scroll all the way to the bottom, because I want you to understand the history of the gaseous sun. Since the sun is not a ball of gaseous plasma, it is made of condensed matter such as liquid metal hydrogen. Please watch this video, not for the explanation of what the sun is, but the explanation of what mainstream astronomers believe and how they came to that conclusion. All right, moving on. By the way, I recommend Brave Browser. It allows you to bypass all of Google's nonsense. Brave Browser will not track you. Use DuckDuckGo for your search engine and use Brave Browser. It works fantastic. Now, looking at the solar data here, spaceweathernews.com. Got a little bit of X-ray flaring, very minor, and none expected. The BTBZ angle is fairly, convergent right now. We've got a fairly straight wind coming in. The phi angle is a little bit all over the place, but it looks like it's around 140 degrees. Solar wind speed is very low, but in the 1 to 3 range for the last few hours, according to ACE. More like 6 or 7, according to Discover. Solar wind speed still very high. Looking at 600 plus, and that is the coronal hole wind stream, although it is weakening a little bit density-wise. Magnetometer, you can see, is still all over the place. KP index is down to 3. It was at 2 there for a bit, as you can see. We are in a pretty massive electron surplus. So you can see that it did get to 10 to the 5th there for a moment, late yesterday, and it's not really dropping back down. So that's a pretty significant electron surplus, and you'll be able to see that reflected in your charging hazards, which there are plenty of. The F2 ionosphere layer is fairly discharged right now. We got a maximum of 9 megahertz. So that's actually pretty weak. The auroras are pretty average right now. Now, let's move on to the About Me section. Your host, Smash-O-Mash. Talk about how I started studying astronomy, and indeed climate change. Well, I formally started studying astronomy when I was about 4 years old, before I ever went to school. Not sure why I started studying astronomy, I just did. And I formally studied it throughout my academic career, ending in 1997, finally. I started studying climate change in 1987 to 1988 in 8th grade Earth Science, and I very distinctly remember studying the North Atlantic multi-decadal oscillation and realizing that if you warm the globe enough, if certain glaciers melt, certain sea ice, freshwater ice, gets into the North Atlantic, it causes the entire northern hemisphere to get cold. I even remember coming home and telling my parents that global warming causes global colding. Now, of course, now I know the sun causes global colding and global warming and everything in between. But let's do a little tutorial here about geomagnetism. So, here you've got a diagram of the solar wind. Your BTBZ is, the BT is the total amount of solar wind coming in. The BZ is the angle. So when you have a very high amount at a very odd angle, it creates a lot of stress on the magnetosphere. For those of you who are not aware of the components, take a quick look at this. Here's your interplanetary magnetic field diagram. So this is generated from the sun. And we're not going to talk magnetic excursions or anything right now, even though it is crucial to understanding this. Right now, all of these fields are weaker than they are at solar maximum. And when these fields are weaker, they get closer to the Earth. And the closer they get to the Earth, the more likely cosmic rays are to infiltrate this entire set of magnetic field force lines. So, in any case, as the solar wind comes in here from your what would be your left, it hits this bow shock, and it tends to get separated into these field-aligned currents, which are what eventually end up producing the auroras. So in the daytime, you've got essentially an incoming positive. Nighttime, you've got essentially an outgoing negative. If that makes sense. Anyway, this is a good diagram. I will leave a link to it in the description below. Thanks everybody for watching. Please don't forget to like and subscribe the videos. Share them on your social media accounts. We'll be making more daily. And one last thing, may the wind be at your back. May the solar wind be at your back and the atherosclerosis absent from your arteries.